This is Unit 7.6, Properties of Equilibrium Constant. These are the key terms you need to know for this unit, including enthalpy, Hess's law, equilibrium constant, enthalpy of formation, K-inverting, and stoichiometric coefficients. Equilibrium constant is a ratio of the concentration of the products to the concentration of reactants. This is the formula you will need to know for that. C and D are the molar concentration of the products. A and B are the molar concentration of the reactants. When K is less than 1, the reactants are favored, and when K is greater than 1, the products are favored. When K is equal to 1, concentration of products and reactants are equal. Le Chatelier's principle is if a system at equilibrium is exposed to stress, the system will shift so as to relieve that stress. There are 3 stresses that can change the system at equilibrium, including concentration, pressure, and temperature. Modifying the concentration can unbalance the reaction. Increasing concentration of a substance shifts equilibrium away from the substance because the extra concentration needs to be used up. The opposite will happen when there's a decrease in concentration, and it will shift towards the substance because more of it will need to be produced to make up for what was removed. The change in volume and pressure can also affect the system. Decreasing the volume will increase the pressure and vice versa. A decrease in volume or an increase in volume will shift the equilibrium to favor the sides that either reduces or increases the number of moles. How does temperature affect equilibrium? Temperature affects equilibrium by the temperature either shifting to the products or to the reactants. Reactions that absorb heat being endothermic, the increasing of temperature will shift equilibrium towards the products. The opposite will happen for exothermic reactions, where the increasing of temperature will shift the equilibrium toward the reactants. This is how you find change in K through temperature. The delta H will be the enthalpy of change of the reaction. T1 and T2 are the initial and final temperature. K1 and K2 are the equilibrium constants at temperature 1 and temperature 2. Equilibrium can be different through various phases. For example, solids are not included in the equilibrium expression because their concentration does not change, remaining constant. The same goes for pure liquids. However, gases and aqueous solutions are included in the equilibrium expression because their concentration and partial pressure change and they can be measured. Let's move on to the question for this unit. So, given the equation and the enthalpy of change, what would happen if H2 gets added? The system will try to reduce the stress by shifting left towards the reactants. What will happen when O2 gets removed? There will be a shift to the right to produce and restore O2. If the temperature increases, since the reaction is endothermic, heat is a reactant. Increasing the temperature will push the equilibrium to the right to absorb the added heat. If volume gets reduced, there will be an increase in pressure. The system will shift to the side with fewer gas molecules. Here, the left side has no gas, while the right side has 2 moles of gas. So there will be a shift to the left. Let's do another question. Here we have an equation. We have oxalic acid turning into 2 H plus ions and an oxalate anion. The equilibrium constant will change based on how we write the balanced equation. For example, if we flipped it like we did in the blue, to find a new Kc, we would first have to take the inverse of the first equilibrium constant. That would be 3.8 times 10 to the negative 6. When calculating this, it will give you 2.6 times 10 to the 5th. Here are the extra resources for this video.